Hey everyone! In this video, I would like to talk about the triangle sum theorem. The triangle sum theorem is a very important theorem in geometry, and it tells us the relationship between the angles in a triangle. So what I'd like to do is I'd like to start off by taking a look at the justification for the triangle sum theorem. I want to talk through the proof and how we know that this is true. So I have a triangle here. We want this triangle to be arbitrary. So it doesn't necessarily have to look like this, but this is just one example of a triangle. And let's start off by labeling this a little bit. So I'm going to label the vertices as A, B, and C. And then just to make it a little bit easier to reference to these, I'm going to label the angles as 1, 2, and 3 as well. Now the triangle sum theorem, what it says is that the sum of these three angles, the three interior angles of a triangle, when you add them all together, you get 180 degrees. No matter what the triangle looks like, no matter how big or how small a triangle is, the angles always add up to 180 degrees. So I want to prove that. I want to justify that that is true. The first thing we need to do is we're going to add in another line. So through our vertex B, so through this vertex, I'm going to draw in a line that is parallel to the bottom of the triangle. So we're going to add in a segment here, and we are drawing it in a specific way that it ends up being parallel to the segment AC. And now on this line, just so we can reference to the line, I'm going to put another point. I'll label that point D. So now we have line BD is parallel to the segment AC. So the first thing here we're going to draw line BD, and it's going to be parallel. So here's my shorthand symbol for parallel. It's parallel to the segment AC. So we can draw in a segment. As long as we have 2 points, we can connect them together to form a line. So that's what we're doing with the line BD, and we can choose where we want it, so we're setting it up specifically so that it is parallel to the bottom of that triangle. Now why don't we label these other angles as well? So let's label this 4 and 5. And now taking a look at those three angles at the top here, angle 4, angle 2, and angle 5, we can see that all together they make up this straight line. So those three angles together have to be 180 degrees because that's how big a straight angle is. So the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5, all three of those together have to be 180 degrees. So there's the 180 we want, but it's not quite the angles that we're looking for yet. So we're going to have to do some substitution. Now, we set up line BD to be parallel on purpose because we need to use that. So now because we have some parallel lines, and then my segments AB and BC, these are some transversals. So two parallel lines cut by a transversal, we have some angle relationships that we can use. Angle 1 and angle 4, these are alternate interior angles. And because they're between parallel lines, they have to be congruent. So angle 1 is congruent to angle 4, which also means that their measures are equal. So the measure of angle 1 is equal to the measure of angle 4. That's just the definition of congruency. On the other side, a different transversal, this time it's BC, angle 3 and angle 5. Are alternate interior angles, and because they're between parallel lines, these are also congruent. So that means that angle 3 is congruent to angle 5. That would be the alternate interior angles theorem. And again, that also means that their measures are equal as well. So the measure of angle 3 is equal to the measure of angle 5. Again, just the definition of congruency. So now we have some relationships between these angles, and we can do some substitution. So instead of the measure of angle 4 in our equation, we can substitute in the measure of angle 1. So replacing the measure of angle 4 with the measure of angle 1, then the measure of angle 2 will stay as is. And then one more piece of substitution. Instead of the measure of angle 5, we'll substitute in the measure of angle 3. And this is it. This is our triangle sum theorem. So as we can see, with a little bit of substitution, we end up with the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 all add up to 180 degrees. And it doesn't matter what triangle we start with, we can follow this same process that we did in this little proof, and we'll end up with this same result. So no matter what the triangle is, no matter what it looks like, when you add up the 3 interior angles of that triangle, it's always going to be 180 degrees. Now the nice thing about this theorem is it also gives us a way to find how big a missing angle is. So for example, if I know how big 2 angles are in my triangle, I can figure out how big that third one is. So the triangle sum theorem tells me that the measure of these 3 angles have to add up to 180 degrees. So 67 plus 38 plus my unknown, which maybe we'll call it x, those 3 angles together have to be 180 degrees. And now we have a simple equation that we can solve to find that missing angle. So adding these together, 67 plus 38, that's going to be 105 degrees. And then we can subtract that from 180. So 180 minus 105, we end up with my unknown angle, so the measure of angle B is 75 degrees. So triangle sum theorem, very useful, but overall it says that the sum of the interior angles of any triangle equals 180 degrees.